Everyone, I'm going to go over the quiz study guide. Starting with question 1, we want to factor out the greatest common factor. So we need to go through each one of these terms and break apart completely. So I've broken everything apart completely, and now what I have to do is go through each and figure out the common factors of each term. So I go through and I see I have a 2 in each. And I also have 2 x's in each. I also have, let's see, 2 y's in each. So the biggest thing that I can pull out of each one of these is a 2x squared y squared. That's just from 1. So I pull out the circled pieces from the one term. And then from here, what goes inside our parentheses is everything that we didn't circle, essentially. So we have 3 x's, a y, and an m in the first, and then we have plus 2x minus, there's a 3 there, and then y to the third power. That's it. Okay, so for our next problem, we're going to factor the trinomial with degree 2 and leading coefficient of 1. It means that we're going to break apart into a couple binomials, and we're thinking what goes in the front spot. The only thing that we could have is x times what goes in the back spot. We could have a 1 and a 12. No, we're trying to get a 7 there. We could have a 6 and a 2. No, trying to get a 7. It is, yes, 3 and 4 that belong there. And how do we get a negative 7x? We get it by a minus 4 and a minus 3. Remember that the outer 2, which is minus 3x, and the inner 2, which is minus 4x, will combine to give us that number of minus 7x. Let's move on to problem 3. Problem 3, very similar to problem 2. Just now we have a 35, negative 35 and 2. First spot, we could only have an x times an x. Now, what two numbers multiply to make 35? And difference between them is 2? 7 and 5. 7 times 5 is 35. Difference between them is a 2. So we're going to have a minus 7 and a plus 5 to give us a minus 2x in the middle there. Our next problem, we have to factor the perfect square trinomial. And one aspect of the perfect square trinomial is the first term is made up of something times itself, and the second and the last term is something times itself. When we factor the perfect square trinomial, literally two of the same exact binomials. 2x times 2x is 4x squared. 3 times 3 is 9. We need pluses here and here to give us the plus 12. The outer 2 and the inner 2, they combine to give us a 6x and 6x, which would give us a 12x in the end. This is our factored form. All right, everybody, next one here, we got factored sums of squares. One property of squares is the front term, something times itself. The back term, something times itself. The difference in between squares is factored with almost the same exact binomial with just a different sign. So we have a 4x times 4x giving us a 16 squared. 9 times 9 giving us an 81. We need one of these to be minus, one of these need to be a plus. I have no middle term here. The outer 2 is a 36x, and the inner 2 is a minus 36x. They cancel off, and that's why we have no middle term with the difference of squares here. So this is a factored form. Okay, so we want to factor this trinomial with degree 2 and leading coefficient greater than 1. So here we have to break apart into two of the binomials. And 1 second, I have a visitor. Okay, so we have to identify um, what to put in the front spot and the back spot. So we have what two things will multiply to 2 to 101, right? The 2x and the 1. Now I have to figure out the 3 and the 1 over here on the right. If I put the 3 here and the 1 here, no, because that's a 2 and a 3, that won't give me 7. I have to flip it. I have to put 1 here and the 3 here. The outer 2 and the inner 2 combine to give us the middle term. Remember that. So we have a 6x and a 1x. That will give us 7x if both of these are positive. So both of these need to be positive. There's our answer. Let's move to the next one. Okay, so for our next one, we have a trinomial, degree 2, leading coefficient greater than 1. And these are usually a little more challenging because we have a lot of options here. We have a 4 and a 1, we have a 2 and a 2. And then over here, we have a 6 and a 1, and we have a 2 and a 3. And we have so many different options that we could test with our binomials. We will put a 4x and a 1x to start, and I'm going to show you the right ones. I actually did this one in class. We're going to put the 3 here and the 2 here because the outer 2 gives us 8x and the inner 2 gives us 3x, which can combine to give us an 11x if both are positive. Both need to be positive here. This is our final answer. Let's move to the next one. So factoring by grouping, we look at groups of terms within our polynomial. And in this case, we're going to group the front 2 and the back 2. And our objective is to pull the greatest common factor out of the group. And then we'll factor from there. So let me go ahead and start off by writing this with its prime factors. So I'm going to pull the greatest common factor out of the first group, and it looks like we have 2 x's that we can factor out. We will be left with a 4x plus 3. And then over here to the right, we have 2 that we can pull out of these two, this group. We pull the 2 out, and we're left with a 4x plus 3, which is nice because factoring by grouping, we are looking at these 2 groups to pull out a common factor. And so I'm going to factor out the 4x plus 3, and I'm left with x squared plus 2. This is our final answer. Okay, so on this one, we're factoring the quadratic. And this one here is very similar to other problems where we're factoring with a degree 2. So first position here, first spot, we're thinking what times what is x to the second times x to the second. And then what times what is 6, and will give us a 5. 2 and 3. We're looking to get a negative 5, so we're going to have a minus 2, a minus 2, and a minus 2. Get our last problem here. And here. So in this one here, we have to factor the greatest common factor and then again. So I'm going to pull out a 2 and an x from each. I see that I have a 2 in each. I also have at least one x in all 3. And I'm going to pull that out. So I'm going to pull out the 2 and 1x from each. And that's going to take the x down by 1 with each. So we have a x to the 6 minus 5x to the third, and then plus a 6 to x like that. So here we have to factor the remaining. It says then again, factor again. We pulled out the GCF, now we have to factor again. And what two terms will multiply to give us the x to the sixth? X to the third times x to the third will give us x to the sixth. What two terms will multiply to give us a 6, a 2, and a 3, both negative. All right, hope that was helpful. That's small.